So today we're going to do just a couple practice problems together, and then I'm going to set you on the task of completing the rest of the applications on this sheet. So I wanted to, on the front page, complete numbers 1 and 3 with you to get you started, and on the back page, numbers 2 and 6. And then you'll be working through the other problems on your own using your notes or kind of what you learn in those couple problems. So this first one is called Serie-ous, get it? Investing. So many investment experts recommend a balance of stocks, bonds, and savings. Stocks have a long history of 9% annual return on average, but there's considerable variation in that yield. Bonds have a much lower annual yield, traditionally about 4%, but bonds involve less risk. Suppose you'd like to invest for a comfortable retirement in 35 years. Given the current economy, you make the following assumptions. So let's just say you'll receive 7% annual interest on stocks, compounded monthly, annual interest 3% on bonds, compounded monthly, and it's a 0.5% annual yield on savings, compounded annually. So I kind of left that one out. We wouldn't really invest in our savings account. Stocks and bonds would be the way to grow our money. So in question 1, determine how much you will have after 35 years if you invest $100 per month in stocks. So let's think about how to set that up. I want to do a series from 1 up to what? I'm being compounded monthly, and I'm doing it for 35 years. So I would want to use 12 times 35 is 420 as the top number of my series because I'm compounding 420 times. I'm investing $100 every month, and this is compounded monthly. So 1 plus number 0.07 is my interest rate, but I'm splitting that up over 12 months. And I want to raise that to the n minus 1 power because I'm taking care of my compounds, right? 35 times 12 over here. So I'm going to plug in month 1, then I'm going to plug in month 2, then month 3, all the way up to month 420, and add all of those together. So math summation, n goes from 1 to 420, $100, 1 plus 0.07 divided by 12, close parentheses, raised to the n minus 1 power. Can you see all that? So if you did it correctly, let's see how much we have. It's still thinking. 420 compounds is a lot. And my battery's almost dead. Oh, there we go. 180,000, $105.46. So actually, now I'm going to skip down. I wanted to do the other problem about stocks. Okay, so I'm not doing number 3. I'm going to do number 4. So number 4's question says, well, how much would you need to invest monthly? So instead of $100, what would you need to invest to have $1 million as your outcome? And then you're going to do this recalculating for bonds. So I'm going to use this equation again, but I'm going to put an X in for that monthly investment because I don't know how much to invest. 1 plus 0.07 divided by 12 to the n minus 1 power. I want that to equal $1 million as my outcome. So what we learned last class is that we can actually take this constant out front and use it as a multiplier to get rid of it. So now this is a number that I can compute on my calculator. So it's basically like this is the interest that I will get. This is my monthly investment. So I'm going to take 1 million and divide by this number to see what I would get for X. So I'm going to do the summation. N goes from 1 to 420. of 1 plus 0.07 divided by 12 to the n minus 1. So I have no starting value listed. It's going to take a minute because it's doing the 420 compounds. So whatever I get as my outcome, so I got 1,801. I'm going to take that and I'm going to take a million, divide by that answer. So I need to invest $555.23 every month for 35 years to reach $1 million if I'm getting 7% interest. So you're going to go finish number 2 and 3 related to bonds up here. So you could pause the video if you want. I'm just going to take a look at 2 problems on the back page and then you can finish the rest. So number 2 says find the common ratio and the sum of the first 8 terms. Round the answer to the nearest thousandth. Determine if the series will converge or diverge. All right, well, the common ratio is 0.75. So I can read that from the formula. Then I want the sum of the first 8 terms. I'm going to do that on my calculator. N goes from 1 to 8 of 20 times 0.75 to the n minus 1 power. Math summation. N goes from 1 to 8 of 20 times 0.75 to the n minus 1 power. 71.99. How are we going to tell if this converges, which means it gets closer and closer to a certain number, or diverges, it goes towards infinity or negative infinity? So we look at the size of the R value, which is less than 1. So this is actually going to be smaller and smaller each time, so this will converge. It didn't ask me what it's going to converge to, but 71.99 looks suspiciously close to 72. And remember, the formula for an infinite sum is 20, the starting value, over 1 minus the R value. So 20 divided by 1 minus 0.75. Oh, it's actually 80. So I was actually off in my estimate. So I'd actually have to go more than 8 terms to see what it converges to. But it does converge. That's really all this question asked me. It converges because the R value is less than 1, and I actually found what it converged to, 80. I'm just jumping down to number 6. Find the sum of the infinite series, so another infinite sum. So remember, it's a sub 1 over 1 minus r. The first term is 80. So let's see, the common ratio. So I'm going from 80 to negative 40, then positive 20, then negative 10. So it sounds like I'm multiplying by a ratio of negative 1/2. So when I do my calculation, I'm going to do 1 minus 1/2. So 80 divided by 1 minus 1/2 is 53 1/3 is what this would converge to. So you're going to take a little bit of time, finish the front and the back, send me a picture of both. If you have questions, please let me know.